really champing at the bit to show their latest technologies.
The next wave of technology.
The show has bounced back with a vengeance.
Hi, my name is Stéphane Deblay and we're here at Hannover Messe 2023. I'm part of Nokia and I will show you this particular demonstration here, which is a demonstration we just created for the manufacturing process industry to show how we can digitalize machine and transform it towards Industry 4.0. In this particular case here, what I have is I've got a typical machine that deals with liquid like you will find in many industrial segments, whether chemical, petrochem, pharma, food and bev, metal and alloy, all use liquid type machine, and we showed how our solution from private wireless to edge and industrial devices allows us to digitalize this particular machine and automate it over time to be more efficient and and the workers also more flexible. So in this particular case, we've taken a 4-step approach in terms of creating the real-time, getting the real-time data from the machine, enabling the worker with information, transforming the data into smart insights, and also finally enabling remote control and full machine automation. So let me tell you a little bit more about this machine. So this machine has 2 different tanks, and in this particular case, mostly was equipped with mechanical analog sensors, which are mostly used today in brownfield petrochemical plants, for example. So the first thing we've done is introduce a number of digital sensors, temperature sensor, level sensor, pressure sensors, etc. inside the machine, added a PLC to control all these elements, the pumps, and an interface to the machine. But then you still have to connect the machine, and rather than laying up cable or private wireless technology, whether 4G or 5G, enable real-time data and easy connectivity without having to lay an industrial LAN cable. So that's what we've done here with a modem that you will see here that connects to the PLC and transfer all the data over the 4G network. In addition, we were able to add other sensors that would typically not be able to be done over a PLC. For example, this IR camera that monitors the tank A temperature, or even this situational awareness camera that's directly connected over the 4G or 5G networks, which give you a real-time view of the machine. In addition, in case you don't have a PLC at all, what you see here, we've also added a Hall sensor on the pump to detect the frequency of the motor, and this is connected directly over the 4G, 5G network to get real-time data from this pump itself that is not digital. So now all of the data goes over the air, over the 4G networks, and reach our OT edge, or mission critical industrial edge, where the edge has the private wireless core network to manage these 4G networks, but we have plenty of capacity to adding additional piece of software from a partner, such as this one from Crosser or Atos, to deal with machine data, do analytics on it, and in that particular case of video, do also video analytics to detect anomalies. We can also, on this particular industrial edge, effectively enable the worker to get real-time data and call, communicate with people or call the control centers, and also enable augmented reality to know how to operate the machine. So this is, in a nutshell, what we've done with that demonstration in terms of the machine to fully digitalize it. So now let me go back to this particular screen, which is the control center view in that particular plant. And as you can see from that screen here, now the person in the control center get access to all the real-time data from all the different sensors inside of the machine. And he's also getting a full real-time overview of the machine itself based on this particular camera that directly connects over 4G networks. So now I'm the worker in the plant. I arrive in the morning and my first job is to heat up the water. So I will get to the machine control in the plant and I will turn on the heater. And I will, with that, be able to effectively heat up the water on that tank, and you will see that the temperature in the tank will increase. The person in the control center is able to see this in real time, but is also able to switch to the IR camera and see the water heating up, as you can see those red dots on the screen that are starting to appear. So with that, they fully understand what is happening in the machine, and then they know that the action I've taken in the field is effectively functioning. So now, let me stop the heating process and move to the next step. So now the worker is in the field, is turned on the heater, but he still doesn't know whether what he's done is effectively functioning. So we're also able to equip the worker with the same information on a rugged device, so he knows that what he's doing is correct. He's also able to call the control center or call a colleague if he is not sure. So that's effectively the first two steps of the transformation, getting the real-time data to the control center, but also to the worker itself. Now let's look at a bit more intelligence. Now we build the intelligence based on the sensor data. And what I will do now is I will transfer water from one pump, one tank into the other tank with this pump here. And you can see you get now the real-time data of the sensors mapped over time, pump rotation, water flow, etc. So now what I will do, I will transfer the water from one tank into the next, and I will induce an error. So I'm now starting the pump. You see the water is now flowing into this tank, and I will turn this tap to effectively lower the amount of water that enters the pump to effectively simulate a blockage inside of the pipe. And you see that after a few seconds, I get an alert that tells me there's less water coming in the pump. That means over time that pump will fail earlier because it will heat up, there's less load on the pump. So again, you see that we built in the intelligence directly to act on machine problems. Let me stop the pump now, but let me show you the next step. You detect this in the control center, you want to send somebody to do this on the machine. Now that particular person just happened to be a contractor that started today and doesn't know how to use the machine. But you can equip him with augmented reality that also runs on the Edge platform to tell him precisely what he needs to do in case of this error. So that tablet is also connected to that 4G network. And what I will do is I will turn on the tablet, scan the barcode on the particular machine, and it will tell me very precisely what tap I need to act on to effectively change and remove this problem. So now he knows very precisely what he needs to do inside of the machine to solve this issue. So now he knows that he needs to turn this tap to the left-hand side to solve the problem. And now the final step, which is a step that will probably take some time in our Industry 4.0 transformation, but we want to show the possibility. Now that you trust the data and you got a reliable wireless network, you also can enable the person in the control center to have direct remote control of the particular element and actuators inside of the machine. So now you can see I can click on that particular button in the control center and activate the pump. But now let's induce a full error on that machine by totally blocking that entry of water. So if you watch the screen here, you will see that we will have something that will happen over a little time. First of all, the machine will detect there is an error like we had earlier because there's less water coming to the pump. But if you look at that screen here, what you will see is over time the pump is not getting enough water and is starting to heat up. And now I've got a pump overheat alert. You can see the smoke coming out of this motor. And now the machine has taken the automated action to stop the pump before something really bad happens. So it basically combined the machine learning data from the video camera to detect the anomaly being the smoke, compare that with the data from the sensors of the machine to realize there was a big problem, that it was better for him to act directly to stop a bigger failure in the machine later. Thank you.